Okay, 1.8, number 9. We're given f of x is equal to x squared plus 6, and g of x is equal to the square root of 1 minus x. And they ask us to do several operations and then find the domain of g. So the first one is just f plus g. All right, and that means f of x plus g of x. And so we write x squared plus 6 plus the square root of 1 minus x. I chuckle because you really can't do anything else with it. They're just asking to add them, and none of these are like terms, so you just leave it as it is. That's going to be the similar thing for subtraction. It's just f of x, which is x squared plus 6. And, you could use parentheses if you wanted to on these things. But, you don't need them. And once you get used to things, you're really just going to make sure you use parentheses when you subtract. So here I'm subtracting, but the entire thing is stuck inside the square root. So I really don't need to distribute that. I can just write x squared plus 6 minus, because the square root is like a giant parentheses anyway. So it's not getting out of there. You can't distribute a -1 or anything to that. Okay, the next one is f times g. Okay, so that means we write f of x times g of x. This step, you notice I skipped up here. I wouldn't say it was the worst thing to once you write it enough times, if you understand what this means, you know what to do. So that's just, this time I will use parentheses because I'm multiplying. And again, I really don't see much to do here. I like products. I mean, I guess I could distribute this. I could write this as x squared minus square root of 1 minus x plus 6 times the square root of 1 minus x. But again, just this is the lesson. So that it's nothing really big there. There's nothing to solve. They're just trying to get you used to the notation. And finally, f over g. This is one where you have to restrict the domain. So we know f was x squared plus 6, and the bottom is square root of 1 minus x. And now this is where the domain comes into play. Okay, so you have to watch out for the denominator has both a denominator and a square root. So whatever's inside, okay, not only does it have to be greater than 0, it can't be 0 at the same time. So lots of times in square roots, things have to be greater than or equal to 0, but if it's a square root in the denominator, it just has to be greater than 0. So I took the whole radicand, the stuff inside the radical, and I made sure that it was just strictly positive. So that's negative x is greater than -1, and so x is less than 1. And there's no square or anything, so that's your domain. I'll even write it fancy. X is an element of R such that x is less than 1. And this is fine too. How else could you write this in interval notation? So negative infinity all the way, but not including 1. So either way this is your set builder notation, interval notation. This is your set builder notation, interval notation, and just an inequality there. All right. So again, these exercises are more like, we just want to make sure you understand what the notation means. We're getting a little bit more involved when we get into compositions and inverse functions. Okay, hope that helps.